Okay, today we're going to be talking about transversals, distinguishing between intersecting parallel and skew lines. We're going to identify the angles formed when two lines are cut by a transversal, and we're going to state and apply properties of parallel lines that are cut by a transversal. All of that. So first of all, let's define some things. We have intersecting lines. They have exactly one point in common, and they're always going to be coplanar. No matter how I draw two lines, as long as they intersect somewhere, I can always draw a plane. There's always like a flat surface on them. If you think about two sticks intersecting, I could always like put a piece of glass on them, and it would always be flat on the glass. Parallel lines are coplanar and never intersect. So if I think about that same sheet of glass and I put two sticks on them, and those sticks never intersect, those are going to be parallel. If I shove one stick through the glass and pretend it doesn't break, and I have the other stick and those sticks never intersect, those are called skew lines. They are never going to be coplanar. And you can also have two parallel planes. So if you had two sheets of glass that never intersected, those are parallel planes. Fantastic. Transversal. So let's talk about what is a transversal. Transversal is a line that intersects two or more coplanar lines in more than one point. So very simply, if we have line H, J, and K, H would be the transversal of lines J and K because it intersects at 2 points. If I had three lines that all intersected, they would all be transversals of the other two. So H is a transversal of J and K, K is a transversal of J and J is a transversal of K and H. Lastly, if I had three lines that all intersected in the same spot, there are no transversals in that set because they don't intersect at different points. So there are no transversals in that one. Corresponding angles, so if I have a transversal of two lines, and let's just throw a whole bunch of numbers in here, 1, 2, 3, 4, 5, 6, 7, and 8. Corresponding angles, 1 is sort of in the top right position, and 5 is in the top right position. So 1 and 5 are corresponding angles. 2 and 6 are also corresponding angles. 3 and 7 are corresponding, and 4 and 8 are all corresponding. So if you think about their relative position in this group of angles and in this group of angles, 2 is in the top right, 6 is in the top right. So those are corresponding angles, or bottom left and bottom left, bottom right and bottom right. That's how you would determine corresponding angles. If the two lines are parallel, that's notation for parallels, putting two arrows on the lines, and we have a transversal. So corresponding angles are going to be congruent. That angle is the same as that angle. This angle is the same as that angle. This angle is the same as that angle. And this angle is the same as, should be only one swoop. This angle is the same as that one. Notice vertical angles are still going to be congruent. Vertical angles are always congruent. So that's good. But corresponding angles are congruent if these lines are parallel. In this case, these lines are not parallel, so 2 and 6 are not going to be congruent. But in this case, they are, so this angle 2 is congruent to this angle 6. If this is 110 degrees, this is 110 degrees. They're going to have the same measure. Then we have same-side interior angles. Same-side interior angles are angles on the same side of a transversal and the interior of two lines. So let's say we have this line and that line in a transversal. Let's only worry about the interior angles. So let's just say 1, 2, 3, and 4. 2 and 4 are same-side interior angles, and 1 and 3 are same-side interior angles. They are on the same side of the transversal and on the interior of the two lines. Now, if these lines are parallel and there's a transversal, same side interior angles are going to be supplementary. So this angle 1 plus this angle 2 is going to equal 180 degrees, and this angle 3 plus this angle 4 is going to equal 180 degrees. That's what supplementary means. It's the sum of the two angles is 180 degrees. Then there's alternate interior angles. So if we have two lines cut by a transversal, alternate interior angles are on alternate sides of the transversal and the interior of the two lines. So if I have 1, 2, 3, and 4, 1 and 4 are alternate interior angles, and 3 and 2 are alternate interior angles. because they are on the alternate sides of the transversal in the interior of the two lines. If the two lines in question are parallel, then alternate interior angles are congruent. This angle is congruent to that angle, and this angle is congruent to that angle. You can kind of visualize this because these are the two obtuse angles, so they're going to be congruent, and these are two acute angles, so they're going to be congruent also. So yeah, alternate interior angles are congruent. Same side exterior, well, if we have two lines cut by a transversal, let's talk about the exterior angles. So maybe I label this 1, 2, 3, and 4. Same side exterior, they're on the same side of the transversal in the exterior of the two lines. So 1 and 3 are same side exterior angles, and 2 and 4 are same side exterior angles. If the lines are parallel, cut by a transversal, then same side exterior angles are going to be supplementary. So if I label these 1, 2, 3, and 4, the measure of angle 1 plus the measure of angle 3 equals 180 degrees. And the measure of angle 2 plus the measure of angle 4 also equals 180 degrees. So same side exterior angles are supplementary. And lastly, we have alternate exterior angles. So if we have two lines cut by a transversal, and we label these 1, 2, 3, and 4, we're on alternate sides of the transversals in the exterior of the two lines. So 1 and 4 are on alternate sides of the transversal and on the exterior of the two lines. 2 and 3 are on alternate sides of the transversal and the exterior of the two lines. So 1 and 4 are alternate exterior angles, and 2 and 3 are alternate exterior angles. Now, if the lines are parallel and cut by a transversal, alternate exterior angles are going to be congruent. So this obtuse angle is going to be the same measure as this obtuse angle, and this acute angle is going to be the same measure as this acute angle. So alternate exterior angles are always going to be congruent. So how do you remember all these? Which is which? Well, same side. If angles are on the same side of the transversal, and they're either both on the interior or both on the exterior, so if it's a special pair, same side interior or same side exterior, same sides are supplementary. It's a whole bunch of S's. Same side angles are supplementary. And then the other end, the alternate interior or alternate exterior angles are always going to be congruent. So that doesn't work. This alternate and congruent don't start with the same letter, but same side and supplementary do, so that's good. And then corresponding angles are congruent. Those both start with C. That's good. I don't know. That's how I remember it. Use that if you want to figure out your own way. If you do, let me know. Okay, bye.